This lesson covers measures of spread, such as mean, median, mode, range, percentiles. Number 1, the 11 cats in a pet store were weighed. Their weights in pounds are given in the line plot below. So, our cats, we have one cat that weighs 3 pounds, two cats that both weigh 5 pounds, and then we have four cats that weigh, no, not four, five cats that weigh 7, and three cats that weigh 9 pounds. So the mode is the number that occurs the most frequently, and that's 7. Most of the cats weigh 7 pounds. There's 5 of them that weigh 7. And then the range is the highest weight, which was 9 pounds, minus the lowest weight, which is 3 pounds. And so the range of the numbers is 6 for the cats, the weight of the cat. So again, mean is the same thing as average, and to find the average or the mean, you add all the numbers together and you divide by how many numbers you have. The mode is the number which occurs the most often, and then the range is the highest number minus the lowest number. On the next one here, number 2. It says each of 7 students reported the number of movies they saw in the past year. Here's what they reported. So they saw 12, 9, 6, 6, 9, 6, and 17 movies. Find the mean number of movies that the students saw. If necessary, round your answer to the nearest tenth. So you find the total of all the numbers, so add all of them together, and it adds to 65. And then you divide by how many numbers you have. And they told us there were 7 numbers, and if you add it up, there is 7 there. 1, 2, 3, 4, 5, 6, 7. And it gives you 9.2857, which rounds to the nearest tenth, because you'll forget to read the directions. They went to the nearest tenth. So to the nearest tenth, which is 1 decimal place, looking to the right, it's 5 or more. So you got to round it up to 9.3. Number 3, it says below are the line plots for 2 data sets. They'd like us to find the mean of it. All right, so we have the number 4 once. We have the number 5 3 times. We have the number 6 twice, the number 7 3 times, and the number 8 once. Now you could have written them out separately or just put them all in your calculator separately. So it would have been 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7 plus 7 plus 7 plus 8. But it's just a lot quicker just to say times 3 times 2 times 3, and then divide by how many numbers you have, which we have 10 numbers altogether. 1, 3, 2, 3, and 1 add up to 10 numbers. So sum all the numbers together, divide by how many numbers, and you get the mean of it, which is 6. Same thing over here. We have 5 4 times, 6 4 times, 7 4 times, and 8 4 times. Divide it by how many numbers there were. There were 4 by 4 or 16 numbers. So that gives the final answer there is 6.5. Number 4 says a car salesman has 6 used cars for sale. They have a mean price of $6,500. What is the total price of all 6 cars? Well, if the mean price or the average for all of them after they were all added together and divided by the total was $6,500, that means that you can just do 6,500 times 6 to get the total amount of them, the 39,000. It doesn't really tell us what the lowest price or the highest price it was. He might have had a car that he sold for $100 and another one that he sold for a ton more than that. But the average of it was 6,500. So if you multiply it by 6, that's the total amount that he has for the cars. Number 5, it says Abdul has scored 25, 28, and 28 in his 3 basketball games so far. How many points does he need to score in his next game so that his average or mean is 25 points per game? I do this one quite a bit with the students because you want to know what number do I need to get like an A at 90%. So what you have to do is add up the numbers you do have, and then you have a missing number that you don't know. We know 3 numbers, and we have a missing number, X, that we want to figure out how to get to the number 25. So add them up. And there's 4 numbers there because the missing number counts as one of them. So add them up, and it added up to 81 plus a missing number X divided by 4. How can we get to 25? So it's kind of a proportion here. You can multiply across, and that's 100. Subtract the 81, and you're going to need 19 more points to get to 25. Number 6. A private college advertised that last year their freshman students on average had a score of 1180 on the SAT. Assuming that average refers to the mean, which of the following claims must be true based on this information? It says, note, more than one statement could be true. If none of these statements are true, mark the appropriate box. It says, last year, some of the freshman students had a score of more than 1360 on the SAT. Well, maybe. They might have had more than 1360. We don't know. They had an average of 1180, so some people scored higher, some scored lower, but we don't know how high they went. Maybe they all got the score of 1180, each and every one of them. The next one says next year, some of the freshman students will have a score of at least 1180 on the SAT. Now this question asked about last year, and this one says next year. So this is about reading to some extent. So reading it here, this answer has nothing to do with the question. So we got to throw that one out. Next one says last year, so it's pertinent because they want to know about last year. The number of freshman students who had a score of more than 1180 on the SAT was equal to the number of the freshman students who had a score of less than 1180 on the SAT. I don't know, could have been. It said it was the mean, and the mean's not the exact number in the middle, that's the median. So if it was the median, that's definitely true, but it was the mean. It's not exactly in the middle. Next one, last year, at least one of the freshman students had a score of exactly 1180 on the SAT. Well, it could have happened. I don't know, possibly. We don't know because they gave us the average. The average doesn't necessarily relate to any one specific number. It's all the numbers added together and divided. Next one, last year, at least one of the freshman students had a score of at least 1180 on the SAT. Well, of course they did, because we wouldn't have been able to get that average if they didn't have at least that number. So that one's definitely going to be true. There's other three could be, but not necessarily. So we can't take that one. It has to be totally true. Number 7, the table below summarizes the amount of milk consumed by a sample of 23 families last month. So if you add up all the families here, 6, 4, and 13, it adds up to the 23 families. So 6 of the families drank 1 gallon, 4 of the families drank 2 gallons, and 13 of the families drank 5 gallons. For these families, what is the mean number of gallons of milk consumed? Round your answer to the nearest tenth. So this was like on the front page. We have 6 families that drank 1, and then we have 4 families that drank 2. So 4 times 2, or you could add 4 plus 4. And then 13 that drank 5. So 13 times 5, or add 13 5 times. And then divide by the total number of families. So the sum of all the milk drank was 79 gallons, and then divide by the number of families. So on average, they drank 3.4347, or 3.4 to the nearest tenth. Number 8. The 8 students in Miss Alexandra's class were asked how many minutes it takes them to get to school in the morning. Here's what they answered. And so here's the list of the numbers. Find the mean and the median. So the mean we've talked about, you add all the numbers up, and they added the 78. Divide by how many numbers there are, and there were 8 numbers. And so that gives you 9.75 or 9.8. The median is the number in the middle when listed least to greatest. So the number in the middle here, there was no specific number in the middle. And so when that happens, you take the 2 numbers that are in the middle, you add them together and divide by 2. And that gives you 9.5. Then on number 10, we have tours with daily sightings. Tours daily sightseeing trip has a capacity of 55 people. Each day, tour officials record the number of people making the trip. The data for a selection of 22 summer days is as described below. And so then they made a chart of it for us. And they made a nice graph with an even width down here, 30, 35, 40, 45, 50, 55. So all the bands are the same width. If you have time, go ahead to the Georgia Health Department's website and look at their COVID chart. Their graph is just horrible. It is no way has the bandwidth the same, and I swear they changed the graphs and the color on it all the time. It's bizarre. Anyway, if you draw a good graph, you're supposed to have an even width on all of them. All right, it says, for these data, which measures a central tendency take more than one value? Choose all that apply. More than one value means more than one answer. Well, you're only going to get one answer for the average, and you're only going to get one answer for the median. You're never, ever going to get more than one answer, but it's possible that you can have more than one answer for the mode. And up here, though, there was only one mode. The number 52 occurred 4 times. The number 46 only occurred 3 times, but if there would have been one more 46, if there would have been 4 of them, then we would have had 2 modes, 46 and 52. So there would have been more than one answer, but no, it didn't happen. So no, none of them have more than one answer. And again, only the mode is possible to have more than one answer. B, suppose that the measurement 32, the smallest measurement in the data set, were replaced by 16. Which measures a central tendency would be affected by this change? Okay, so they popped out the smallest number and they replaced it with another small number. So that is not going to change the median at all because they did not change how many numbers were on the list. The median is the number in the middle of the list when listed least to greatest. Well, we replaced the smallest number with another small number. So the median is not going to change. The number in the middle is still the same number in the middle. It didn't juggle at all. The average is going to change though, because the sum or the total of all the numbers added up is going to be different. Letter C says, suppose that starting with the original data set, the smallest measurement were removed. Which measures the central tendency would be changed from those in the original data set? Well, if you just remove that number, just pop it out and don't, use it, that means the median is going to have to change because you have a different number of numbers listed. So the number in the middle has to change because you've changed how many numbers are there. And of course, the mean is going to have to change because you took a number out. So the sum of all the numbers is going to change. And then last of all, it says, which of the following best describes the distribution of the original data? Choose only one. Okay, negatively skewed looks like this. It has its tail to the left and it rises to the right. Positively skewed starts over on the left with the bump and then it goes down with its tail to the right. Symmetric has the bump in the middle. Another way to think about it, when it's positively skewed, I tried to make a positive sign there for you guys. When it's positively skewed, the mean is usually greater than the median. But anyway, looking at the data here, if you look at the point in the middle and you connect them up, you can see the tail of it is going to the left and it's rising over to the right. And when it's rising over to the right, I told you that it's negatively skewed. So that one is negatively skewed. Number 10. Students at a major university in South Carolina are comparing a serious housing crunch. Are complaining about a serious housing crunch. Many of the university students, they say, have to commute too far to school. And university officials should build more housing near campus. The official's response is to perform a study. A study report in the school newspaper features the following histogram summarizing the compute distances for a sample of 71 students. It says down below, based on the histogram, using the midpoint of each data class, estimate the mean commute time of the students in the sample. Carry any intermediate computations to at least 4 decimal places. Okay, so we don't know the exact number. So between 1 and 5 students had a frequency between 0 and 20 for their commute. And then between 6 and 10, the commute and distance is 6 to 10 miles for about 22 students. And then the commute is between 11 and 15 miles for 15 students, and so on. So if we were going to do the average of that bandwidth between the number 1 and 5 is the number 3, because 1 plus 5 is 6, divided by 2 is 3. So 3 students had 3 miles. So the 3 miles is the frequency for about 20 students. And then 8 miles is the frequency for about 22 students. Again, they had numbers somewhere between 6 and 10 miles. We don't know the exact mileage, so that's how come we have to take the middle number they said. Take the average and multiply it by how many people had that number. So 22 students went about 8 miles each time, and about 15 students went 13 miles each time. And so that's like the other ones that we did the mean of. So 20 occurs, the number 3 occurs 20 times. The number 8 occurs about 22 times. And then the number 13 occurs about 15 times, and so on. So you add up all the numbers and divide by how many numbers there are, and you get 10.2. Notice the bandwidth of all of them is the same again. They counted 1 to 5, 6 to 10, 11 to 15. If you make your own histogram, it has to be even like that. Number 11. In a survey, 11 people gave the following ratings for a local politician on a scale of 0 to 100. Identify the values that are outliers. If there's more than one outlier, separate them with commas. If there are no outliers, click on none. Okay, so the simple definition of an outlier is a data value that is much smaller or larger than most of the other values. So the number 13 here is much smaller than the other numbers. So if it's much smaller or a number is much larger, it's an outlier. The mathematical definition of an outlier is 1.5 times the interquartile range. So 1.5 times quartile 3 minus quartile 1, which if you did it on this, we're going to get 18. And you take quartile 3 and add 18, so any number greater than 71 is going to be an outlier, and then quartile 1 minus 18 takes you down to 23, so any number smaller than 23 is an outlier. So that's the mathematical way to do it, or you could just eyeball it there. And obviously 13 is way outside of the numbers. Okay, number 12. Answer the questions below. The 10 members of the swim team completed the following numbers of laps at today's practice. So they have those 10 numbers there. Which measure should we use to summarize the data? If you look at all the numbers, there's no outliers there. When there's no outliers, you use the mean. On the next one, if you look at the list of numbers, you can see that 87 is way outside all of those numbers. It's an outlier. So when you have that outlier, you're going to choose median. So no outliers, mean. If you got an outlier, median. And this one talks about grades, but don't give any numbers at all. Since there's no numbers, we can't compute a mean or a median. So we're just going to have to go with the mode. Number 13. Our class recorded the temperature at noon each day for 20 school days in April. The lowest temperature was 70 and the highest was 79. The table gives the mean, median, range, and interquartile range of the data. A, select the best description of spread for the data. So spread is how far apart the numbers are. So that immediately tosses out mean. So that's why it's not this one. They didn't ask about the mean. They asked about the spread. The spread is how far apart the numbers are. That's not the mean. The mean is the measure of central tendency of where the center of the numbers are. So it's not that one. So going back to that one, the range of the temperatures, the largest to the smallest, that's the range of the temperatures. And so it's the first choice. And the last one can't be it because they did a range of the days, not of the temperatures. We don't want to know the range of the days. We want a spread of the data. And the data is about temperatures, not the days. So that's why it's not this one. And this one, it says, select the best description of center for the data set. So the center, like I said, is mean and median. It's not range. So it's not the first one, range. So it's going to have to be the second one here. They said to look at the mean or the median. And honestly, I don't know what the heck this thing's about. I think maybe the printer didn't print it well, so we'll just ignore that. Okay, 14. Here are the ages and years of 8 professors at a college. What is this percentile of professors who are younger than 37? So I added up how many were younger than 37. There were 4 of them. out of 8 professors. So 4 out of 8, 50%. Okay, and then number 15. A national chain of department store ranks its 1,250,000 salesmen by the monetary value of their sales. Ann's sales are at the 55th percentile. Abdul's sales are at the 86th percentile. Which of the following must be true about Ann's sales? So if Ann sells at the 55th percentile, that means she's 55% above all the other people. She's got 45% above her that outsold her, but she's above the average salesman. Abdul is doing great. He's only got 14% that sold better than him. He's at the 86th percentile. Which of the following must be true about Ann's sales? Ann had sales lower in value than 55% of the sales force. No. She had sales higher than 55% of them. The value of Ann's sales were about 55% of the chain's total amount of, that'd be saying like the total amount of money they sold. No, not at all. It's just saying that she outsold by 55%. Let's see. Yeah, of their sales. It didn't say that how much they sold, just that she's in the 55% of selling stuff. Ann had sales higher in value than about 55% of the salesmen. That one's true. The value of Ann's sales were about 45% of the chain's total. No, 45% sold above her, yeah, but no. Okay, which of the following must be true about Ann and Abdul's sales? Ann's sales were higher in value than Abdul. No, Abdul did much better. He got 86th percentile. Only 14% sold more than him. Both Ann and Abdul had sales higher in value than the median. Well, sure they did, because the median would have been 50th percentile. And they both did better than the 50th percentile. They both did a great job. And Abdul again did the best with 86th percentile. Next one. The serum cholesterols of 19 individuals are listed below. Find the 10th and 75th percentiles of these cholesterol levels. Well, unfortunately, just like the median, what you got to do is list the numbers least to greatest, which is kind of painful. And then after that, what you do is this formula of n plus 1 times the percent of what you're trying to find. So n being the number of numbers in the list. So n here is the number 19 because that's how many numbers are in the list. So 19 plus 1 is 20. And if we want the 75th percentile, 20 times 0.75 is 15. So we want the 15th number in the list, which was 240. So the 10th percentile of the data, I did it up here. So again, n is 19 plus 1 times the percent. And we wanted to do it for 10%. So 20 times 0.10, so that would give you 2. So the second one in the list, which is 189. All right, you guys have a good day. Hopefully I'll see you again.